Okay, Brainiacs, for Alien Institute's 100th video, we're going to look at some number theory for the numbers, in particular the integers from 1 to 100. Out of the 100, 2 of the numbers are perfect numbers. Other numbers are called abundant, and the rest are called deficient. Additionally, we will discuss some of the English names given to certain numbers. Mathematicians love numbers and their patterns, but they also are intrigued by the irregularities. The English names we give to the numbers have patterns, but there are some irregularities that seem strange. And that's what we're going to talk about today. To start off, we accept the fact that we have to give names to our mathematical symbols. Now, it's easy to accept that the numbers 1 through 9 could have been given any name in a base 10 system. But what is strange are the numbers 10, 11, and 12. Additionally peculiar is the order of the syllables for 13, 14, 15, all the way up to 19. When we look at 20, it has the T sound like the number 2. 30 has the Th sound like the number 3. This continues. 4, 40, 5, 50. The pattern follows to 9, 90. So logically, you'd think the number 10 should have been 1T or something like that. Now 11 was not only the first mission to land on the moon, and it's not only the first double-digit prime, but it's also the first number to follow a set of 10 that doesn't have an obvious pattern. I've heard that 11 comes from the word endleophon, which means one left over after 10. So I guess since 12 doesn't have an apparent pattern, we could guess that 12 means 2 left over after 10. Now 13 gets a little better at getting the pattern back on track, but it still is strange. Yes, teen is short for 10, but the order of the number parts is strange. If we say 21, 22, 23, then we might expect 13 to be teen 1 for 11, teen 2 for 12, and teen 3 for 13. Staying with the pattern of accounting for the tens and then adding the ones. Now I do remember an English nursery rhyme where they account for the ones first. The nursery rhyme had the line in it saying, 4 and 20 blackbirds baked in a pie, using 4 and 20 rather than 24. Also, the Germans number this way all the way up to 100. See this video here for the example. The German number for 39 is 39, literally translating to 9 and 30 for 39. By the way, about the blackbirds, if I recall correctly, the blackbirds got their revenge by pecking off the maid's nose. Okay, now let's talk about perfect, abundant, and deficient numbers. The definition of a perfect number is a positive integer equal to the sum of its proper positive divisors. The word proper meaning to exclude the number itself. Between the numbers 1 and 100, 6 is the first perfect number. The numbers that divide into 6 are 1, 2, and 3. Remember, we exclude 6. When we add up the divisors 1, 2, and 3, we get 6. So the sum of the divisors equals the number we were finding the divisors for, making it a perfect number. There's a formula called the Euclid-Euler theorem that generates perfect numbers. It's 2 to the quantity p minus 1, that minus 1 times 2 to the p minus 1. When you calculate the 2 to the p minus 1 part, it must be a prime itself to continue. These are called Mersenne primes. If the 2 to the p minus 1 doesn't turn out to be prime, then we won't get a perfect number. So we move on to the next prime number till we get a Mersenne prime. Anyway, there are two perfect numbers from 1 to 100. See if you can find the second one and put it in the comments if you find it. Next are the abundant numbers. For an abundant number, you add up the divisors, excluding the number itself, and the result of adding the numbers is greater than the number you started with. Example, the number 12 has the divisors 1, 2, 3, 4, and 6, and the sum of them is 16, which is greater than 12, making 12 an abundant number. Finally, a deficient number is a number where the sum of the divisors, less the number itself, is smaller than the number we are analyzing. The number 8 is a deficient number. Its divisors are 1, 2, and 4. These divisors sum to 7, which is less than the number 8, making 8 a deficient number. Note, the prime numbers are a subset of the deficient numbers because every prime number qualifies since 1 is the only divisor other than itself, and we exclude that proper divisor, and 1 is less than any prime number. Shwoop! The prime is a deficient number. For the integers from 1 to 100, there are 2 perfect numbers, 76 deficient numbers, and 22 abundant numbers. So we've looked at some characteristics of numbers from 1 to 100, but as we know, the numbers go forward infinitely. Intuitively, it would seem that the perfect numbers are infinite, but no mathematician has proven it yet, if it's true. The ancient Greek mathematician Euclid famously proved that the prime numbers are infinite, and if someone could prove that the Mersenne primes of the form 2 to the prime minus 1 are infinite, that would automatically prove that there are an infinite amount of perfect numbers. So whether it's theoretical or applied mathematics, here at Alien Institute, we know that there are some incredibly daunting problems in our world, similar to proving the primes are infinite or that rockets can go into space. And we hold the belief that all these daunting problems can potentially be solved. In our efforts to solve these daunting problems, we also know that successful or not, whether we crack that code or not, our effort, our valiant effort in the attempt to solve any difficult problem does something quite remarkable. It expands our mind to places where sometimes the impossible becomes the possible.
Hey, Alien Institute crew, don't forget to strike the like, subscribe, comment, and share. Also continue learning by watching more AI videos.